Alright,
Wasn't going but yeah.
so,
That's supposed to be.
well, the SI unit for heat is energy, and the SI unit for energy is a joule.
Loser.
Alright, these, quiet down, class. These notes yesterday is a good review because all of these variables will be necessary. Trust me, I know that probably will keep you up, but you're gonna have to go to the back table to do that.
I said,
Or,
I can see.
Oh, wait, we already, never mind.
I don't mind. Alright, so, what we have to do is shift from the kinetic molecular theory to the actual gas laws. And we were at the very end of class yesterday discussing and contrasting the difference between a theory and a law. And we stated that a theory is based on data, it is based on experimentation, it is our best educated, based on data, based on experimentation, explanation. It's not really a guess, it's our best, I got you, best explanation to date. Now, this is why, this is what we would call the educated guess. Because it is based on actual experimental data. Now, a law is a generally observed behavior. It means it does happen. So these things do happen. So what we discussed yesterday are 6 postulates of the kinetic molecular theory. You will go into the kinetic, again, what I stated yesterday is my explanation for you, hopefully to make it a little easier. You will have a little project on that on Friday to take a little, hopefully a reinforcement, deeper dive into the kinetic molecular theory. Again, that is our best explanation to date for what we're about to discuss and see. So tomorrow we'll have various hands-on opportunities and demonstrations and things like that where hopefully you guys will get to do some stuff or at least see some stuff, experience some stuff. And then we'll do some of the math. So tonight's goal is for you to actually review these notes and start getting these gas laws in your brain. The first one, scientist Robert Boyle. What we start to do is manipulate some of these variables. What he did is he held the temperature, that's not hard to do, and the amount of a gas constant. Again, that's not hard to do. The amount and the temperature were held constant. So in other words, you just need to be in an environment where you're at a constant temperature. You can control temperatures in environments pretty easily. Even back in the day, they were able to at least have some climate control to some degree. And you can easily not change the amount of a substance if you have it contained in some way, shape, or form. So here's what Robert Boyle started to see when you hold the temperature and the amount. So let's see if you guys did some review last night. I doubt you did, because you probably were studying for your heat quiz.
Of course. Oh, yeah.
Nope.
So we have amount mole, we have T temperature, these are the two he held constant. What are our other variables that we've already discussed that are important to describe gases?
Well,
I
let's
can't say
see.
energy's not, but energy and temperature are going to be directly related. Yes.
P for pressure.
The P for pressure,
Pascals, yeah.
and there was one other major one,
V for volume.
Yeah, and
and
volume.
the V for volume. We're going to use all of these variables to describe gases because gases are not easy to describe because, of course, they're these kind of very interesting state of matter. So what Robert Boyle did is he held these two constant. And he started to look at how these two actually start to fluctuate. And here's what he found out when he did these things. And we can do these things, again, you guys will have your hands on these. It's actually a pretty decent little lab. That if you increase the pressure, you start to squeeze the gas a little bit more. Again, holding these constant, the volume actually shrinks. So an increase in pressure causes the volume to decrease. And if you were to increase the volume, he found that the pressure would, guess what? Decrease. Does anybody know mathematically what type of relationship this is called?
Abusive relationship.
Up, down
Jeremiah.
is kind of how maybe we would teach it at a lower level, but up, down is actually called what in big girl terms?
Left, right.
Conclusion.
You got that.
I'm on the scale.
I'm a big kid now.
Let it know.
Great job.
Right now.
Ascend, descend.
The word would be
Left and right.
inversely.
Oh yeah, I never.
We all knew
We
that.
were getting there. We were getting there.
Yeah.
That was the next day.
We tried this.
And I can demonstrate this in a matter of seconds.
Oh.
Put a bomb in there. Buh.
It's on video.
It was on video. Only joking.
There's lots in there. Drink everything.
And Peggy. We all should be.
Don't bring Peggy into this, Brad.
We all should be copying down the note. Not side conversations, because then you'll be like, "Oh, I didn't get time to hack the note down."
Fancy too.
I don't think my voice sounds like
I don't think my voice sounds like it does when it turns to the whine voice. Stop,
Why?
don't go forward. Everything goes,
Right.
what? Ooh, that's your order voice, not your whine voice. You use both. So if the amount and temperature of the gas are held constant, the product of the pressure and volume actually ended up being a constant value. In other words, and we'll show you that here in a second, the pressure and volume have to be inversely related. Again, remember this is just happens. It's not explaining it. The kinetic molecular theory tries to help explain that. This just happens. The pressure and the volume of a constant amount of gas at a constant temperature are inversely related to each other.
You never gave us an example in a matter of seconds.
I have it right here. I would like people
It's
to
been
get the
minutes.
notes before we do the explanation.
It's no longer seconds, so you just lied to your channel.
Ah, jeez.
You're gonna have to post an apology video.
I
Yeah.
will not post an apology.
You're about to
because
get
once
canceled.
you're done, then I will do the demonstration in a matter of seconds.
You're about to get canceled.
Cool. Can't lie your channel.
I'm gonna make a Reddit post about this.
Again, this really is a fascinating observation. If you notice this note right here, the conclusion, he started just taking different pressure and volume measurements, and he would put them together, and they would find out that they equaled a constant value. For instance, I'm going to do very easy math. All right? Let's say he got a pressure of 4, and you can give any unit you want, ATMs. And he got a volume of 4 milliliters. Okay?
Dang.
When he multiplied these two things together, obviously it's 4 times 4, it would equal 16 ATM milliliters.
Interesting.
Now, keeping the same amount of gas and the same temperature, he would then double the pressure. So if he doubles the pressure, that would go to 8 ATMs.
Wait a minute.
But what he found out was, when he did the sum of these two things, it still equaled 16 ATM milliliters. Because what he found out, as he doubled the pressure by a factor of 2, the volume went down by a factor of 2. In other words, when he did this the first time and the second time, they always ended up equaling the same constant number. Meaning that this relationship, there's something going on in nature when it comes to gases that allows us to help describe them. And of course, this one is called Boyle's Law. And it does have a mathematical equation that helps us use it on a day in and day out basis. Of course, I do want to define inversely for some of us in the room. I didn't say who. When one goes up, the other one goes down. So we can do the up, down, up, C, down, C. Again, it's just big boy, big girl words, that's all.
Upseas is a big boy word. Are you
No,
kidding me?
inversely is. Up C's and down C's.
You're slow.
I like going upseas.
Uppies, I need uppies.
And this leads us to a very, and I mean very handy formula. And we call this formula Boyle's Law.
Let me go home.
Let me go home.
Let me go down home.
Actually, don't let me go home.
Well,
Let
once
me
we,
go.
well, once we have cooking class, then I'll be able to go home.
Oh, that's the end of the day.
We have our first,
Now.
we have our first gas law formula. That is not a difficult gas law formula,
I want to sit on
and it is very usable. In other words, if you know some initial conditions or we know some final conditions, we can usually solve for some of the other things. That gives us Boyle's Law, our first gas law formula. Yes. I'll just answer that question now.
Oh.
Because I'm sure someone's about to ask,
What
do
law
we
is
need
that?
to know the formulas? Yes.
You heard it here first. Do
Oh,
we
yeah.
need to know the formulas?
All right. So here's my seconds long demonstration.
I
Pay
got
attention. 30 minutes
At
later.
this point, I've put this plunger to 10 milliliters.
That ain't no plunger.
I have now capped that so it is airtight. We have a constant temperature in this room. We are temperature controlled. Now the amount of gas in here is, of course, the same. And all I need to do is increase the pressure and we can see clearly what does happen to the volume.
Right.
It went down. In fact, we know there's pretty good pressure here because if I let go, it just pushes it back up by itself. I don't have to do anything. Again, increasing the pressure decreases the volume. And if I decrease the pressure, I can increase the volume. And so we can easily use these plungers to do that type of thing.
Incredible.
And you will.
That was more a minute long.
It's like slightly.
And that
Can I
is
close?
kind of, I mean, Boyle used a contraption maybe a little larger than this, but this is exactly kind of how Boyle did his experiment.
That was
Shout out
incredible.
Boyle.
Well,
Yep, shout out Boyle. Sponsor us, please.
good old Robert Boyle did that, and all these people started saying, hey, wait a second. If you hold some of these other variables constant, I bet you can start manipulating gases in major ways. And then the next person that came along, his name was Jacques Charles.
Shout out.
Sure, it wasn't Jacqueline.
Shout out Jacques.
Yeah. He's on the flag.
Jacques Charles went ahead and held pressure.
Shout out Frank.
Actually, no.
Shout out Raid. Shout out Legends.
Don't sponsor us, Frank.
Please sponsor us, Raid.
Please speed.
Please.
Notice- Notice what's going on here. Pressure and the amount of gas have now been held constant. Now, so what are we relating here? Yeah, we're going to be relating temperature and volume. And now
That's right.
there's a little bit of a difference here in his conclusion. See if you guys can catch it very quickly.
You don't have a promise of God today, so I guess it's just
We
no
can,
promise.
we can definitely write a promise of God as you write the conclusion of Jacques Charles's calculations.
It's the quotient.
Why is that so fun to say?
Inverted.
Why is that so fun to say?
You definitely do not want to try to do a day without one of God's promises, that's for sure. Even if you don't need it, I need it.
I need it.
What is today's date? The 23rd? 24th? Ooh, we're moving.
Yep.
Yes.
So that is day 55.
We're only on day 55? Oh my god.
Oh wow, this fits my mini money this morning.
Mini mode. Which
Remember
you
said
should
it would take
finish.
6 hours?
We could just quit the notes.
That was just
Now.
one little story.
We
Well,
should finish it right now instead of.
jeez, I bet. That would.
Oh, what?
Make everyone happy.
Yeah.
And we should start from the beginning because Jefferson wasn't there. He came in
That's
late.
true.
and then we
Actually,
should, if we
just
don't
need to
finish
go
it, we
birth
should
to
go.
death.
If we don't finish it, we should do it next Monday, then Tuesday, then Wednesday. Yeah, if we don't finish it, sermon, are you slow?
We should
No, you're
spend the rest
you're
of the year
slow.
studying your life.
I literally finished the sermon.
We need to learn some chemistry.
Screw his.
No, you do not.
Lesbian war.
When quotient on, you know, this was one pile. This one's gonna be
Oh, hi, baby.
Did you say oh hi baby girl?
Video. No, that's on video.
There's worse stuff on video.
You're a horrible dude, Brad.
I will reward those who diligently seek me with a heart of faith. Hebrews 11.
David wrote Hebrews.
Did you say David wrote Hebrews? Are you kidding me?
More
All right.
or less.
The letter of
David wrote
Hebrews
Hebrews.
is anonymous.
No, David wrote Hebrews to the Church of Hebrew. Hebrew.
All right, moving on.
It's a letter.
There is a difference. I heard a couple people say it already. The quotient is equal to a constant volume. So let's do some simple math with that, and let's make sure we kind of understanding what's going on here.
He wrote it in the
So in other words, if I do a volume, again, let's use the same numbers, 4 milliliters. And we do a temperature, okay? And we're gonna find out that you have to use the Kelvin scale here. So all temps must be in Kelvin. You're gonna write this later, so it doesn't matter. You can take it down now if you want. Must. It must be in Kelvin. Must be in Kelvin. And so, but in order to just 4K,
Sorry, Bradley.
and so we can clearly see. I mean, you guys can do this math.
One.
This is
Equals 1 milliliter equals 1.
1
How many
MLK.
Ks do you need?
MLK was like
ML per K.
Milk.
MLK was like 3 weeks ago.
Yeah, we didn't even get to celebrate them.
Yep.
It's
Chad
milliliter
compass in this
per
video told him to give us
Kelvin.
MLK.
But that's okay. Let's double the volume. If we double the volume to 8, the only thing that can happen to still have this equal 1 milliliter per K,
Gotta double the other
Is
one.
what?
You gotta double pressure.
you have to double the pressure as well.
Oh, it's right? Oh.
Exactly.
That is the only thing you can do. So as one of these increases, what does the other one have to do?
So it's
And so
Yeah.
this one is, of course, a direct relationship.
Direct.
Oh, that's really
You know, not like the whole online dating thing.
And of course, just to make sure that that note is in your notebooks, bold and underline, all temperatures must be in Kelvin.
Amen. Amen.
What? Oh shoot, Frank's Revolution.
What? 0 correlation.
Murder Mystery Board.
And this is a perfect ending for today's class.
Amen.
We're basically
thinks-
almost
wait.
already home.
We're not leaving yet.
Wait, are we going
Tough
home?
math.
Who thinks that they can figure out the law, the formula that you would use? Jack has quickly raised his hand. Charlotte has quickly raised her hand.
They know the answers, so just call them.
Charlotte's gonna try. Go for it.
Wait, no.
It's gonna be similar to this.
Yeah, but it's just.
For
It's gonna be quotient.
Charles.
Right?
So V1,
Charles.
T1 is a quotient would equal
Oh,
what?
Barkley.
Charles Leclerc.
Now, be careful here. This is what you will see in many textbooks, but you know that Mr. Lesniak is not a fan of quotients at all. And it's,
You gotta
main-
multiply again.
Timer.
it's mainly because you guys mess up. Mainly because you guys sometimes mess up the volume. You kind of solve for inverses and things like that. So to simplify that, to help you with your algebra, we can do it this way. V1 T2 is equal to V2 T1. These are the same formula, but this one down here, this one right here, will save you from making algebraic mistakes.
That's right, brother.
Oh,
You hear?
So again, same formula, you'll get the same answers, but that one will save you from making algebraic mistakes. We will wrap up the gas laws lecture tomorrow and have our, hopefully some good demos and all that other stuff.
You heard it here. Stay tuned, guys.